Thank you. And I'm so sorry you guys don't get to see Kori present. She's amazing. If you don't know her, I encourage you to meet her, ask her questions about this work. I'm presenting, the lucky guy gets to present her work largely, supported by Leonardo, Frid, Katie, Burchard, who I haven't met, myself, and Jim. And I think I could speak for Jim and I. We were cheerleaders, reviewed a little bit of code and the concepts here. So the first three did the heavy lifting for sure. I think this is a theme of this conference. Seriously, like, it's one thing to think, okay, let's make a model. It's another thing to input it and to get good inputs. I feel like that is truly a theme of this conference. And so it's funny that our team all seem to talk about dogs. You guys have seen and heard about some of this, but I'm just going to shore it up for you just in case. Landfire, the large federal program that maps vegetation, fire, and fuels characteristics for the U.S., also developed state and transition models for all of the ecosystems of the United States, trying to capture natural disturbance regimes prior to European colonization. So we have the states, and we have succession, and we have the fire and other disturbances that move pixels around or cells around within the model. From that, we can get several things such as mean fire return interval for each ecosystem or biophysical setting. That in turn is tagged on to our biophysical settings data as an attribute, so we can make maps such as this one that represents pre-European colonization fire frequency for the US. Many of you know or have seen this, but it always just strikes me how much fire there was in the United States historically. The models were parameterized with expert information, triangulated with literature review and local data, right? It's this very iterative triangulation between what we know and what we can glean from literature and local data. And bringing in the fire history literature seems like a great first step, but it's very difficult. It's very hard because different scientists use different methods. I love the creativity, but sometimes you just wish people would do things the same way. They report this stuff differently, so it's not always apples to apples. Then also they summarize results for different temporal and spatial scales. Further, the way ecologists in these papers classify their ecosystems might be different from ours. So there's always that crosswalking challenge as well. So with all that, Kori, I think, summarized the challenge with these questions really well. Can we improve those land fire mean fire return interval estimates by systematically calculating fire frequency from tree ring fire scar data? And also, it's very important to us that we can communicate to land fire users the strengths and weaknesses of the models so that they are informed and know how much work they might have to put in to improve those, how much trust they can place into them. So Kori, I believe, largely selected this area because this is a place she knows well, Oregon and Washington, and specifically winnowed down the work to the dry mixed conifer and the ponderosa biophysical setting areas as represented on the map here. So she then took the data along with the collaborators from the International Multi-Proxy Paleo Fire Database tree ring fire scar data. I'm not a dendro guy. I probably didn't phrase that quite properly in a musical way, but here's a chart from that database. And for those of you that are not familiar with these charts, each horizontal line represents a tree. The vertical lines represent a fire event. And as many of you already know, tons of fire up to around 1900. So she was able to mine this data for several sites across her study area. So basically, here are sites that were in the area. She further winnowed down the sites that would be used by the biophysical settings. Then the team further constrained those sites with these criteria. First, the data was constrained to 1700 to 1900. Then sites had to have more than 2 trees recording a fire event, and more than 25% of the trees had to record fire events. The idea was to get the large fire events, not just the lightning strikes that would impact one tree, for example. So after the winnowing, down to 55 dry mixed conifer sites represented in the darker blue, 2 mesic mixed conifer sites represented in the lighter blue, and then the sort of pink sites are 5 ponderosa pine sites. So I believe that Katie made this beautiful chart. That's what I heard. That's what Kori mentioned, I believe. And I'm going to let you soak it in for a minute. So, and I'll orient you as well. On the y-axis, we have the fire return interval from 0 to 60 years. We have the sites represented by each bar. And I wondered, in a box and whisker plot, are these individual things called a bar or what? You know, I didn't know the term for each individual. Isn't this the whole box plot? What's the individual thing? That's what I want to know. What's it? I'll call it. Oh, okay. Thanks for that clarification. I don't read these very often. I'm like, what do I call that? Okay, you guys understand though. The horizontal dotted lines represent the mean fire return interval estimates from the land fire models. So 22 years for the dry mixed conifer, 15 for the ponderosa pine sites. And automatically you see that a couple of things, I think a couple takeaways. Land fire estimates were not wildly different than the fire scar. So we didn't double or order of magnitude off, if you want to use that term. Also, almost all the medians were less than the land fire estimates. So we did feel like it was a meaningful difference. And so then the team took the next step of, well, summarizing by the biophysical setting. So this is a similar chart, except for you have each box representing a biophysical setting. And again, we have the horizontal dotted lines representing the 22 years for the dry mixed conifer and the 15 for the ponderosa pine. And again, it's just another way of saying the estimates aren't too different, but they are meaningful. Then the next step was to try to apply those new improved results to some models and to see what the results would be. So looking at one set of sites, I don't know how to say that word, so I'll just leave it. I don't want to butcher it too badly. The idea was to, okay, look at the land fire estimates, then bring them down to the mean of the median from the site data. So in our biophysical settings models, this is not that difficult. It's really would be refreshing for you all that do really complicated modeling to play with our models. It's really simple to go in and change the probabilities. So we have up to 5 states per biophysical setting. That's what you see on these bar charts. We have the percent of the landscape in each one of these classes or states. And the gray bars represent the land fire, mean fire return interval inputs, and then we have the ones from the site. So you see that once you adjusted the model, we did get some changes. For example, we got a doubling of the early class for the dry mixed conifer. We got a reduction of the closed classes and an increase of the mid and late open classes. So this would match our hypotheses for changing the fire return intervals. Also, the hope was to reparameterize a model in a way that did not change fire severity tons. So, and I think they were able to achieve that. We did get a little bit more surface, a little bit less of the mixed, and a little bit more replacement. So basically, we're feeling that, thank you, that this is a good thing to bring in this more localized, calculated data from this large database that's collecting fire scar data. So can we improve those fire frequency estimates? Sort of the baseline or the take-home message here was that we can reinforce what land fire had in the model and make some minor improvements for these biophysical settings. That may change wildly across the country as we look at other sites. The fire severity, I'm not, again, a dendro person, but it seems super hard to get fire severity information from dendro data. I don't know how that works. Maybe you know more, but I think that is a challenge of using this data. Can we inform users? I've always wanted to have a confidence-ometer little indicator on top of our biophysical settings that tells users, you know, about the confidence we have in the inputs. So I think that this could really help us do that. We could change our descriptions and our models to inform users to say, hey, you know, you may want to look at this model more. Looking more into tree ring data suggest our estimates on fire returnable may be high or low, whatever the case may be. So some next steps, does ponderosa pine burn more frequently than dry mixed conifer? That will be a question to look into. And is the fire regime tied to vegetation type? And again, challenges there, as we mentioned, with the crosswalking between the literature, even the site information, and the biophysical settings. Luckily, Kori has a lot of intimate knowledge about these landscapes and was able to make those linkages. For me, I could not have done that with any confidence, but she was able to do that. So with that, I believe I came in a little early. I'm sure I didn't add a lot of the nuance and interpretation that she could have, but there's one of her kids and a doodle in Oregon. And with that, we have Jim, we have Leonardo, myself here to try to answer questions.